Hi everyone, I'm Hiransh Narirwala and I'm excited to present my project, the Adaptive IoT Thermal Regulation Solution. This system intelligently controls temperature using an Arduino MKR WiFi 1010, a DHT22 sensor, and a 12-volt fan. By combining IoT, automation, and environmental control, this solution allows for smart remote management of thermal environment. This system can be very much useful and could be implemented in various departments, such as a data center, to automatically regulate the temperature in server room. Secondly, in industrial equipment cooling, in order to prevent overheating and prolong the lifespan of an equipment. In animal habitats, to maintain the ideal temperature in animal enclosure. Fourthly, smart home ventilation system to improve air circulation and maintain a comfortable temperature in a room. Now, without any further ado, let's dive into the details.
So these are all the components that I'll be using for my project. This is the Arduino makeup board 1010, which is mounted on the breadboard. These are all the connector or jumper cables, female to male, male to male, female to female. This is the battery holder. These are the batteries, 1.5 volt batteries. This is a 1K resistor. This is trans a transistor. This is the humidity sensor, and this is this is a fan. This is a 12-volt fan.
And this is the Arduino Cloud Create platform. Here, I will go to things. I want to create a thing for my project. Yeah, I will name it as IoT Temperature Control. Yeah, I'll add a thing. Its name will be set. It will be set temperature. The variable will be float type. It will be read and write only and on change. So I want to create four widgets. So accordingly, I will create four variables. Second will be override switch. It will be boolean type. It will be read and write. Third will be fan control. It will be boolean type. And last one will be current current temperature, and it will be float point. Periodically at 5 seconds. These are the four 4 variables. I'll connect my Arduino board here, MKR Wi-Fi 1010. Now enter the Wi-Fi credentials. I think I made a mistake here. The current temperature will be read only. We'll go to dashboard. Create the dashboard here. I'll name it as IoT Cloud Controller. It's renamed. We'll first make a slider. We'll name it as set temperature. We will keep it horizontal. We'll give it the values as -15, maximum temperature of 80 degree. This -15 to 80 degree is the temperature range which is of our DHT22 sensor. We will link it to set temperature variable. We'll link it. Done. We'll add switch. We'll name it as uh, override switch. We'll link it to override switch link variable. We'll add one more switch. We'll name it fan control. Link it to fan control variable. And here a slider here. We'll name it current temperature temperature. We will link it to current temperature with minimum as -15 as you remember and 80. Done. Now we come to the logic of the program. Logic, and it consists of 3 main functions. Now first main function will be regulate temperature. And this function will be called from our loop function in the program. Now if temperature is greater than the set temperature, then turn on fan, else turn off fan. Right? This is our first function, and it's going to control the entire system. Main function is to control the entire system. Second will be turn fan on off. If fan control turn on fan, or turn off fan. This is our second main function. and this is just going to inspect the value of the fan on property, fan on boolean property to be specific. This fan control is just going to see what is the boolean property of this of this thing, whether it is on or off, whether it is true or false. It is only concerned about turning on or off the fan. Third function will be system update system. Now here, if override switch is enabled, will turn fan on or off, else regulate temperature. Now in this property, the update system property, if the override switch is enabled, then it will call the function turn fan on or off. This function it will call, and accordingly, if it is off, else it will go to the regular temperature function. It will call the regular temperature function, and this will check if override enable flag is checked. Now we have some callback functions. Callback functions, right? So we have three callback functions. First will be onset temperature change. It will call regulate temperature. Now if we do any kind of changes in onset temperature change, for example, this is in our property, if we change this set temperature, for example here it is 30, now we change it to 28. So when we change this set temperature, it will call the regular temperature function. There is this, it will see what is the current temperature, and if it is greater than the set temperature, and accordingly it will turn fan on or off. Next callback function we have is on override switch change update system. Now if our override switch is turned on, it will call the update system function. Here it will again check the flag of the override switch. If it is true, then it will then we can according to ourselves, here it will check, if it is turned on, then it will check the fan controls, whether it is turned on or off. If it is turned on, the fan will turn on. If it is turned off, the fan will turn off. And if the switch is off, then it will call the set temperature function, regular temperature function. Last will be on fan control change. Similarly, it will call the update system function. So here is the entire logic behind our project. Sorry everyone, it is the next day. Sorry I couldn't complete the video yesterday. I had some work to do. So I'm back again, straight from where we left off. Here is our code which we wrote yesterday. What I will do is I will connect this USB cable, connect this micro USB cable to my Arduino board. It will recognize the Arduino board and it will show up here. See, here it has been recognized. Now I will upload it. But before it being uploaded, first it will verify the entire code, whether it is right, whether there is any mistake in coding, whether in the language, wherever there is a mistake, it will show up. If not, it will be uploaded to the Arduino board. It will take little bit of time to verify and then upload to the board. It says it is being uploaded now. That means there is no problem in our code. And now it says done uploading. Now if we click on the serial monitor, we'll get all the updates regarding our Arduino. Say it is connected to my Wi-Fi. Now what I will do is I need my dashboard. I need the controller. What I will do is I will keep this here, keep this here. We have all the information now. What it is doing, it is connected to the IoT cloud. It is giving us information about the temperature every 5 seconds, which is great. Now the temperature we have set here is 30 degrees Celsius, and the current temperature it is showing right here, it is 27.4 degrees Celsius. Now there's a big gap. What I will do is for demonstration purpose is I will reduce this temperature to, let's say, 28 degrees Celsius. Okay, I'll reduce it to 28 degrees Celsius. Now here I have a lighter. Here is our DHT sensor. What I will do is I will increase the surrounding temperature with the help of this lighter. I have turned this lighter on. Soon we will be seeing that in our monitor. What is the current temperature? Right now it is saying that it is 27.4 degrees Celsius, but we can notice that it has been increased to 27.5 degrees Celsius. We'll just take a few more seconds now. It is 27.6, 27.7. As soon as we hit 28 degrees Celsius, the fan will turn on. It is 27.7, 27.8, just 0.2 Celsius more, 27.9. I think that is enough. Soon it will hit 28. It has hit 28. Anytime the fan will turn on. And right there, the fan has turned on. We can see the fan control has been turned on automatically. It is adaptive. It has turned on by itself. Now I'll point this fan towards the DHT sensor. The temperature will drop down and the fan will turn off. See, it is reducing now. 28.2, 28.1, 28, 27.9. The fan has turned off. You can see right here. We also want to check the override switch. Now I will turn on the override switch, the fan control. I will turn it on. Now, no matter the set temperature, the override switch is on, so fan will turn on. You can see the fan has turned on. And now when I will turn off the fan switch, when the override is on, the fan will turn off. And the fan has turned off. And there is one more thing, we can control it via the IoT Cloud. I have this IoT Cloud remote right here with the dashboard built right into it. along with my account. So we can see the current dashboard, the override switch is on. So when I will turn the fan control on, the fan will turn on. And when I will turn it off, fan controls off, the fan will turn off. So likewise, I can control it from control it remotely from my mobile, from wherever I am. So that was the project. This project showcases the potential of IoT and automation in creating smart systems that can adapt to environmental changes, all while being remotely accessible. I hope you like the project.